It's time to talk about scope and namespace. These can be confusing concepts, but I have an analogy that I think will make it a little easier. We're going to think in the context of the United States. There are certain things that we generally agree upon. The president is Joe Biden. In the context of computer science, we would say we have a name president that is bound to the person or object, Joe Biden. We also have a national pastime. The name national pastime is bound to the game baseball. We can think of baseball as an object. These bindings could change over time. At some point, we'll have a different president. The name will refer to a different person. But generally, if you ask someone in the United States today who is the president, their answer will be Joe Biden. And if you ask, what is the national pastime, they'll say baseball. We can have some other contexts in the United States. For instance, we could have a house. Let's call it House 1. In House 1, they're having dinner, and dinner is chicken. So within this house, the name dinner is bound to the object chicken. You can imagine another house, House 2. In House 2, they have a name dinner also, but it doesn't refer to chicken. In House 2, dinner is tacos. So we have the same name in different contexts, but they refer to two different objects. But ask anyone in House 1 who the president is, and they'll still say Joe Biden. Same with House 2. And there are two people in House 1. One person is Alice, and Alice is reading a book. The book Alice is reading is Diary of a Wimpy Kid. Randolph also lives in House 1, and Randolph is also reading a book, but he's reading a different book, Catch-22. So within the context of House 1, we have two different people, Alice and Randolph. For each of these people, the name book has meaning, but it means something different for Alice than it does for Randolph. Finally, let's define a clubhouse. And the clubhouse has a president. Her name is Betty. Notice that we have the same name in two different contexts. In this larger context, we have president bound to the name Joe Biden. In the clubhouse, we have president bound to the name Betty. If you ask someone in the clubhouse who is the president, they'll say Betty. But once you step out of the clubhouse, whether you're in House 1 or House 2 or just on the street, if you ask someone who the president is, they'll say Joe Biden. And notice again that dinner is defined in House 1 and House 2. If we go into House 2 and ask what's dinner, they'll say tacos. But if you go out on the street and ask what's dinner, you might get a strange look. Unless it's Tuesday, then it's still tacos. In Python, similarly, we have this binding of names to objects. And we have the sense that those bindings might exist in one context, but not in another. The scope of a binding is the reach that that binding has within your program. In our example, we would say that president and national pastime bound with Joe Biden and baseball have global scope. As long as they're not overwritten, these bindings are available anywhere within the program. Once we go into House 1, we say the binding of dinner with chicken has a local scope within House 1. If we go deeper and think about Alice, then she has a binding that has local scope, book with Diary of a Wimpy Kid. She still has access to the global scope binding of president with Joe Biden and national pastime with baseball, and she has access to the enclosing scope binding of dinner with chicken. She doesn't have access to the binding in House 2 of dinner with tacos, or the binding of president with Betty in the clubhouse. So we've talked about several layers of scope. We have a global scope. In Python, those are the bindings that are defined at the module level. On the other extreme, we have local scope. Those are the variables that are defined in the context of the current function. In between, we might have something called enclosing scope. So if Alice is a function within House 1, her binding of book with Diary of a Wimpy Kid has local scope, while the binding of dinner with chicken has enclosing scope, because Alice exists within House 1. And the binding of president with Joe Biden has global scope. There's one more level called built-in scope. All of the keywords and the built-in functions that come with Python, like the print function, are said to have built-in scope. A namespace is all of the new names that are defined at a particular level. So the global namespace would include these two bindings, President and Joe Biden, national pastime, and baseball. The namespace of House 1 would include dinner with chicken, and Alice's namespace includes the binding book with Diary of a Wimpy Kid. Let's see how this works in an actual program. At the module level, we'll define our global scope bindings, President, with the string object Joe Biden, and national pastime with baseball. And let's just print those values out. And we'll run that to make sure it works. Excellent. Now let's add a function called House1. Within House1, we said we had dinner. And dinner was chicken. So within our House1 function, let's print out what each name refers to. We'll start with President and national pastime. And then we'll print out dinner. And back to the module level, we'll leave these two print statements here, and then we'll call our House1 function. Let's run this. Pretty much what we expected. At the global level, things are still the same. At the House1 level, we still have access to the president and the national pastime, and we've added a name binding dinner with chicken. But let's see how ubiquitous that binding is. After we call the House1 function, let's try to print out the value of dinner. Notice we get some red underlining here, and when I run, I get an error. Dinner is not defined. So even though we've already called the House1 function here, the scope of the dinner chicken binding is local to the House1 function. After we leave the House1 function, that binding no longer exists. So we don't have access to the dinner name. Let's add Alice to House1. And we'll print out all these values again. And we'll call Alice from the House1 function. Running this, everything is as we would expect. Alice knows that the president is Joe Biden, that the national pastime is baseball. Alice lives in House1, so the dinner she has is chicken. And her book is Diary of a Wimpy Kid. Of course, if we defined Randolph here also, he wouldn't know about the binding between book and Diary of a Wimpy Kid. Instead, we would bind book with catch-22. We're not going to code up our entire example, but let's look at Clubhouse. We said that Clubhouse had one new binding, which was president. And the president is Betty. Notice that president has this beige underlining. And if we hover over the word, we see that president shadows the name president from the outer scope, or the global scope in this case. And that means that president in the global scope still refers to the object Joe Biden, but within the Clubhouse, the name president will temporarily refer to the object Betty. That's not an error. PyCharm just wants to make sure you know what you're doing. Let's go ahead and print out the value of the name president. And we'll call the Clubhouse function and run our program. So we see that at the Alice level, president is Joe Biden. At the House1 level, president is Joe Biden. But within the Clubhouse, president is Betty. Now we might think that we've actually changed the object that the global president name points to. But in fact we haven't. We can print it out again. And at the global level, the president is still Joe Biden. So within the Clubhouse, we had a namespace that includes the name president, shadowing the global level name president, but only temporarily. This looks like it would be an assignment to that global name, but it's not. In fact, any assignment to a name in a function is going to create a new name in that namespace. If we actually wanted to modify the object that the global name president points to from within the Clubhouse function, we'd have to use the global keyword, and we'll get to that concept soon.